Great. The webinar is just open. We already have our first couple attendees. Hi, guys. Good morning, good afternoon, good evening, depending on where you're joining from. Thank you so much for joining us today. Welcome from around the world. We have an incredible panel for you guys today with different technical leaders from around the world as well. So we'd love to hear where you're joining us from. Where is everyone joining from today? Would love to know if you want to drop it in the chat. I know that we've got a lot of different attendees from around the world. I'm over in the Bay Area in California myself. We're finally enjoying a little reprieve from the fires. So fingers crossed we keep that going. I hope everyone's having a great day so far. So let's jump right into today's session. For those of you who don't know me, if this is your first time here, welcome. Thanks so much for joining us. My name is Maddie Watt. I'm the Senior Manager of People and Programs at the Hive, and one of my main functions is leading the Hive think tank. I'm going to tell you guys a little bit about that in just a second. But real fast, ground rules for today. This session is being recorded. It will automatically be sent out to everyone tomorrow. Thank you for those who were patient with this being rescheduled. We really appreciate it. If you have a colleague or a friend who was not able to attend today because they had been scheduled for the original date, please go ahead and share the link with them. It will be sent out automatically to you tomorrow. Also, for all of those attendees who had pre-registered for the original date, we went ahead and signed everyone up so that way you guys all automatically get the email link sent to you. So video will be sent out tomorrow. Other thing, questions. We love questions. Please, please, please ask questions. Your most burning, brightest questions, all about data sharing, whatever challenges you might be facing at work, please let us know and use the Q&A button. So to ask a question, if you look at the bottom of your screen, you're going to see a bunch of buttons, and one of them is Q&A. So if you can please click that button and then ask your question through that. That way it's all in one nice, neat place for our moderator, Ellen, and she can look at the questions that way. And you guys can also upvote different questions that you want to see answered most. Okay, so let's get really into what the Hive Think Tank does really quickly before we pass it on over. So what is the Hive Think Tank? For those of you who are new, and even those of you who are returning, it is an ecosystem of entrepreneurs, corporations, and thought leaders. We are bringing you events about every other week, sometimes twice in a week. And we also post our thoughts in a blog online on our Medium page. I will drop the links for our Meetup page and our Medium page in the chat. Our Meetup page is the best way to stay up to date on all of our events. And we'd like to thank our sponsors. If you would like to find out about sponsoring the Hive Think Tank, please go ahead and email me. I will drop my email in the chat. And then last but not least, I want to let you guys know about an event we've got coming up here, and it will be on October 6th. We are just going to open registration in a minute here, so I will drop the link to that in the chat, and you guys should sign up for that as well. It's going to be an incredible event. So without further ado, I'm going to let TM Ravi tell you very briefly about what the Hive does before we jump right into today's session about data sharing. We have an amazing panel for you guys, and I hope you enjoy.
Thank you, Matty. And so just a little bit more on this event, Supply Unchained. There has been kind of, I would say, significant disruption on one side during the COVID crisis. And on the other side, because of the rapid evolution of the gig economy in the last mile and the middle mile, around delivery and fulfillment, as well as kind of micro-fulfillment, warehousing, and so forth. And kind of a growing pressure on sort of local because of sustainability and other sort of political issues. So this is an incredibly fascinating topic, and we have two kind of very important thought leaders here to talk about it. So I hope you can all join. So thank you all for joining today. My name is TM Ravi. I'm the Managing Director and founder of the Hive. And so the Hive is a venture capital entity, very focused on data and data-related approaches as applied to the enterprise and a few key industry segments. So we collaborate. We are one subclass of venture capital that's called a venture studio. And we spend a lot of time with potential entrepreneurs to work together with them to help them create companies in this general area. I'm especially pleased today to reconnect with two friends, old friends, Ellen Friedman and Ted Dunning, and of course to meet new friends, Suparna and Joanna. We've been doing events with Ellen and Ted for almost the beginning of the Hive think tank, and when they were, of course, at MAPR. And so it's my great pleasure to introduce Ellen Friedman, who's principal technologist at HPE, who will moderate today's event. Ellen?
Ellen, I'm so sorry to interrupt. One thing I wanted to say is that we will also be doing a poll. So I just wanted to remind that real fast before you went and jumped in, and I put that in the chat too. Okay, sorry, thanks.
Great, thank you. And thank you, Ravi. It's just a huge pleasure to be back and doing something with the Hive Think Tank again. I just want to quickly introduce our panelists to start with, and have each one just say the briefest thing about what they do with their day job. So let's start with Joanna. This is Dr. Joanna McKenzie, who is a principal scientist, a data scientist at the Data Lab Scotland and Innovation Centre in Edinburgh. Joanna?
Absolutely, yes. I am principal data scientist, which means I coordinate what projects we do for people, and I work with people across the Scottish economy in all sorts of interesting sectors to help them get better at using their data.
Fantastic. And we also have Dr. Suparna Bhattacharya, who is distinguished technologist with the Hewlett-Packard Enterprise HPE AI Research Lab. Suparna?
Yeah, thank you, Ellen. Very happy to be here. So I, as you mentioned, I'm working at the AI Research Lab, and my focus is on how do you get better data for AI, and we focus on how you make data better especially for making AI trustworthy. So thank you.
And Suparna very kindly is joining us very late at night in India, even though she has this beautiful backdrop on a beach here. We know it's especially good time.
I'm in Bangalore, India, yeah.
Yeah, fantastic. And our last panelist is Dr. Ted Dunning. Ted is the CTO for Data Fabric at HPE. Ted, tell us a little about your day job.
So I'm driving Data Fabric strategy across HPE, but also I wear multiple hats. One of the things I've been involved in lately is contributing to an open source community for agricultural data called Agstack. There's a bunch of other things too, but those are the big ones.
Okay, and so I think rather than all of us calling each other,
we should ask Dr. Friedman what her background is too.
Thank you, Dr. Dunning. My background is I am a principal technologist with HPE, focusing on HP Ezmeral software, especially on Data Fabric. Just a reminder to those of us who've followed this for a while, Ted and I both, as Ravi said, used to work at MAPR Technologies. MAPR was acquired by HPE, and the MAPR data platform is now the HPE Ezmeral Data Fabric, and hence part of our interest in it. And so from this point forward, I think we'll switch to first names. And I just want to jump right into our topic. Our title today, Data Sharing for Data Science. This is actually a new frontier. There's just an explosion of interest in this, and for very good reason. And it may sound simple. When people hear data sharing, they sometimes think this is just a matter of getting permission from whoever has the data that you want, whether that is data that's open and being shared, or if it's data that's you have to get permission, or it's for sale, even if it's internal to your own organization in different departments. you have to get permission. And of course, that is important, but that is just the tiny tip of the iceberg here. That's the beginning of the process. And the issues go way past this, because you have to also know that the data exist. You have to know where to find it, understand what's actually in that data, if it fits your situation, if it's a mismatch for how you're using it, how will you get access to it, and so on and so on. And so it's a tremendous thing, but there's also a huge interest in it for obvious reasons. Data science is growing. People's interest in using AI is becoming widespread. That's no longer an unusual thing. People are increasingly interested in understanding how to get value from data, whether they're smaller data sets or huge data, distributed data, and so forth. But one thing that really caught my attention is I've learned from several of our panelists that different people who are doing these big data science projects are also combining data in really surprising ways. They're using data sets you wouldn't automatically think go together to address a problem. And it turns out the insights you can get from that are much stronger in many cases than you would get from kind of a single type of data or a single data source. And the last issue that I think is driving this, and some of the issues that we'll talk about today and talking about the challenges, is for each of you working with data, think about it for a moment, whether it's in your organization or outside. Data often, usually, is not collected specifically for the purpose for which you're using it. Data might be collected, say, for billing, but you as a data scientist are looking at those transactions, doing fraud detection or doing something else. So you're going back into data that may have been collected for one goal. You're going to use it for a different purpose. And obviously that can lead to additional challenges in terms of preparation and mismatch. So that's kind of the ideas behind all of this. We have three people who have different points of view, but all have experience with this. So let's jump right in. I would like to start with Joanna. Joanna, in your organization, you work with many different groups, academic and in industry, basically across Scotland. And some of those are actually fairly new to working with data science and AI. So how do you help them see how to get value from data, and what are some of the issues they face?
We have a number of different approaches at the Data Lab. One of them touches quite strongly on skill sets, because when people are new to data, building skills is one of the most important things. I think it's quite interesting because we have a course for leaders in organizations that are not data driven, and it's to help them understand better what they can do with data, how they can get value from it. And we do it as a MOOC, and we do it in person, and it's all about driving that data ecosystem in Scotland. In that MOOC, we say that to people that there are roughly speaking 3 ways you can get value from data. You can get value from data by improving your operations, so doing what you do better. You can improve your decisions, so you can reduce the risk that you're taking and make better decisions for your organization. And the third one is monetizing data, and it is possible to monetize data, but we often caution them that it's one of the hardest ways to get value out of your data. And there's lots of different reasons for that, which are very relevant to the discussion today. The reasons, the context of data is very important, what it's been collected for, the resolution that it's done, the quality of the data that you're getting. If you are collecting it for yourself, for your own organization, your own purposes, you can control those things. If you're trying to then find a client who wants that data, who will pay you money for that data, you need to be meeting their needs as well as your own, and that's much more difficult. And of course, the value that you can get from the data in different contexts means that the value that data has, the amount of money that people will pay for that data, is very context specific. It's not always very obvious how much it will be worth to a particular client, and agreeing on what the value of the data is, how much we should charge for it, is a big challenge. It's difficult to do. So that's one of the challenges. The other challenge is, of course, that it's not just the data itself. It's not if you've got a CSV file or a lovely relational database with tables in it. That information itself doesn't always stand alone. You often need to know a lot more about the data. So if it's survey question data, does the survey question data tell you which order the questions were asked in? Does it tell you the population that you asked the questions of? All of these things that you need to be able to gain insight in different areas. And for sensor data, simple things. How was your sensor calibrated? How long has it been running? How long ago since it was last checked for its quality? Is it wearing out? And all of these things impact the accuracy of the data. And if you want to monetize that data, if you want to sell it to somebody else, you need to be able to say, I can meet your needs. And that's one of the hardest challenges.
So that's all really metadata that's explaining, and that's really, all of those are really good examples of metadata you need for understanding what the data can be used for. Yeah.
And both of you, your point about the value of data being very much context dependent, it does not just apply to this idea of if you want to monetize data. In these other 2 points that Joanna made about getting better value from data, it's better operations, making better decisions, whatever you're using that data, whatever insights you're using, the context is enormously important, both in framing the question, what are you addressing with the models that you build and so forth, but at the other end is how do you take action on the insights that you get from models? You have an actual practical, put it into use. Otherwise, it's a very shiny, exciting project, but it doesn't really deliver value. And all of those are dependent on the actual situation, even if you're just using data from your own organization. So a lot of the issues that we're talking about apply whether people are trying to buy and sell data, if they're using data outside the organization, or they're using it internally. Joanna, do you see people also beginning to barter data? Is that a new
I haven't seen that. I haven't seen that. And I think it's because it just is ultimately challenging. What I do see is people making data open more often. So repositories being built of data in different contexts, which can be useful to different places. A lot of map data in Scotland. Map data is quite a big thing, where repositories of open maps, LiDAR measurements of forestry and crops, all these sorts of things starting to become much more common to see. But of course, all of these things had a cost to develop. So the organization has to have gotten that money from somewhere and invested in that data for some reason. And it's kind of them to put it out for everybody else to use. But it's not necessarily, we can't necessarily say it's always going to be free, because it had a cost.
We're not going to see the high street on Saturday closed off to traffic and little booths set up and people drinking cider and going booth to booth to collect data, I guess. Although I kind of like that. Kind of like that image. Let's take a moment. We have the results of our poll here, and this is just to get a sense of our audience and to hear from you. And it looks like we have quite a number of people who have experience as data scientists, but more of our audience have other roles. And of course, in working with data, it's not just the data scientist or even the data engineer per se, but all of these people with different roles are involved in these questions of how do you curate data, how do you find data, how do you deliver it, how do you judge a project to decide whether to fund it. And so I think that there's really issues for everybody besides the people who actually get their hands on the data and use it directly. So Maddie, thanks for doing that poll, and thank you everybody for responding. Just moving on here, I alluded to the fact that I've been intrigued. I've certainly heard Ted and Suparna talk about this. I've talked with Joanna a little about this idea that people are combining data sets in surprising ways, or more accurately, the types of data that are being put together are maybe not ones that you'd automatically expect. Ted, can you just touch on that a little and give us a few examples of how people are using data in slightly surprising combinations?
Yeah, I've seen this happen a number of times, and Suparna has been involved in some of these as well. One of the most common sorts of data that we see being reused in very interesting ways is weather data. A lot of it, for instance, was originally developed to facilitate air travel or aeronautical applications. But then we see it being reused for things like controlling disease, because that can help us understand, along with the physical conditions that the weather is impinging on, whether a disease will propagate and where we should apply this. But we also see it in econometric applications. A number of retailers use weather as a prominent signal for demand prediction. It's not just predicting who's going to buy umbrellas, but also who's going to buy anything at all. Will they go to an outdoor event? Will they want to stay inside? Or even will they just want to stay at home? And so you could see online, offline switches due to weather impacts. But there's all kinds of these sorts of reuses of data in interesting domains, wherever you see that it'll change the behavior of people or a physical system.
And Ted, you've taken as an example weather data. I find that really interesting. I used to do a little bit of work and consulting for here in the US, our NOAA, our National Oceanographic and Atmospheric Administration. I was so impressed about how they were using data, remote sensing data from satellites. But of course, that was being used more in the ways that you expect of actually studying literally the hard sciences of atmosphere. But now it's moved on. People are using those data sets, and those are open data sets, and I know there are equivalents in other countries, using those data sets for a wide range of different things. And Joanna, I think you have direct experience with that, not just as an observer, right?
Absolutely. My last roles were all in the wind industry, developing wind farms, working with operational wind data and predicting how much energy you should get from a wind farm. And NOAA data was crucial to that. Across the wind industry in Europe, that repository of global data going back decades was our best way of benchmarking long term. Because of course the long term matters. What the weather's been like at a particular spot on the ground. And as the wind industry has developed, certainly in Scotland, it's a massive industry now. But as it's developed, we've got new techniques that can actually improve on the resolution that the NOAA data provided. But go back 10 years, 12 years, that was where everybody started when they wanted to build a wind farm. It was very, very valuable data, very valuable information.
And I'm assuming that data like that, I mean, again, this isn't specifically about weather. You can apply this comment to basically any type of data, but we started on weather, is that it's got value in the moment. In some cases, the value is in some of these IoT systems is the value to be able to collect data and understand, monitor, predict what's happening in real-time data. So the need for being able to deliver data in real time, to do streaming architecture, streaming analysis. Ted and I have written about this a lot. But these data also have value from looking back from a history. So
Yes.
being able to keep it in an archive so you can go back and say what was happening over this period of time, or what was happening in advance of the catastrophic failure that we hope we never have again in that machine. Can we look at early enough to find early indicators of some sort of a failure signature? So we're really talking about things across different time frames as well, I think. Yeah.
And there's one of the difficulties there is the simple complexity. You'd think that weather would be simple, but no, it isn't. They report it differently. They reanalyze it. So they essentially run a predictor from the data that they have to predict the past. And it's tremendously complicated to find the data you need.
So it's complicated to find the data you need. I think it's also complicated to know what data you need. And I mean that from 2 points of view. You need a certain level of experience to say that data would be a good indicator. I mean, like what you alluded to before, Ted, is I certainly wouldn't just automatically go, weather data is a good way to predict things relative to the needs of supply chain. In terms of a retail industry or manufacturing. I mean, maybe it's more obvious for manufacturing if there's a flood or whatever, but weather is not the first thing that I would think to go to, but people with more experience are beginning to understand that that's what they want to do. But the other piece is, if they know that that's the type of data they want, how do they know who has it?
Yes. And it's really hard to even imagine what kinds of data people are inventing methods to collect. So one of the big wins in economic industries is that a lot of the companies that handle, for instance, job tickets, the hourly reporting that people say in the restaurant industry report, what people are doing is they're aggregating that information, and that becomes a nearly real-time indicator of economic activity in an area. Who knew? How would you even know that that's there, or that people are offering that data?
Well, I want to jump now to a really interesting story. I've had a little flavor of this in a previous presentation I did with Suparna and with Ted. So we've said that data is being used and combined in interesting and new ways, but a different issue about this ability to really deliver value from data and sharing data with different groups is to think not just who is the data producer or curator, who has the data, who is the data consumer in the sense of who's the data scientist or the data engineer who needs to work with that data and build models, get insights, but who is the end consumer of the data. And that may be different, maybe a different organization or different people within an organization. And how do you deliver those insights to them? And this can be very different in terms of geographical distribution, certainly different in terms of the type of expertise that people have. So the people who collected the data have a certain kind of background. The people who are analyzing data have different skills. The people who you're handing those results to need to use it in the context within, their expertise. And so jumping to Suparna, you've told a beautiful story about working with people working with a nonprofit organization called Digital Green, which is actually a partner, a member of this new Open Foundation data initiative that was announced in May of 2021 from the Linux Foundation called the Agstack. I think Ted alluded to that in his intro. But there, the goal is taking very technical, very modern data and modern data science methods and using that to help agriculture, to improve agriculture, but not just for large organizations, for small farmers who represent an enormous amount of food production in the world. And those are people who have very different expertise than the people doing the data science. So it's a flow back and forth, not just to them and back from them. Tell us a little about that and what are the challenges and how are those challenges being addressed?
Yeah, so you were giving an example of Digital Green, this organization. So as you said, there's a lot of benefits from precision agriculture, and enormous amounts of data of different kinds can be combined, and there's so much research going on. What Digital Green is trying to do, and there are many such organizations like this, they're trying to work with extension agents and really deliver those kinds of recommendations, best practices to farmers. They actually, they have about 2 million farmers that they have been able to reach around the world. In fact, majority of them are in India. A large proportion of them are actually women. And the way they do it is that they don't just deliver the information as is. What they do is they actually create videos which are demonstrating those practices, and those videos are enacted by the local people. It's related to the local conditions. And they have been able to do this for this scale, but if you know that there are about more than 500 million smallholder farmers across the world. So how do you scale that, to be a much broader level? And also the other problem that they have is, how do I really make this much deeper impact? Because you're constantly getting new research on agriculture and new advances. We are getting, how different crops grow, what's the impact on climate change, and what are the right practices that are both environment friendly, sustainable, as well will give them, the farmers, good returns. And that, how do you really connect that piece of information that you get to these farmers and in their context? So maybe if you have like a farmer who is based in Karnataka in India, where maybe the irrigation practices are, you have pot irrigation, and then maybe there's a farmer in Bihar where there is really rice fields, and they're very different kind of irrigation, they're very different kinds of soil conditions. So how do you know, basically, Ted, can I summarize it very nicely? He says the problem is, how do you find the common ground between the data that is being produced, all of this information about weather and soil and all of this research? How do you really connect that and give that in that contextualized form to that farmer? And so one of the ways to do that is, for example, is the work that we're doing with Agstack. Ted is really being able to say, which is the geolocations, and say, okay, everything that's related to this given location and given time is potentially relevant. And maybe that's an indicator of some kind of metadata that you could add to connect the dots. There is also things like crop names. The crop names are different in different places. You might use the scientific name, you might use a local name. So how do you really relate those things? And then you also want if you really want the research to reach these farmers, there's also a lot of rich information that you can get by seeing, as you're saying, there's a flow backwards. So as the farmers are trying these practices, you're seeing how which practices are actually getting adopted and what are the yield that they are actually giving you, at the productive or not. And that feedback is very useful for these farmers, for the scientists who are really connecting with these farmers. And so how do you get that data back now, all the journey? So you need to have this ability to track the trajectory of the data, where it's gone through, and make those connections all the way through. So I could keep saying a lot about that, but
because it's such an exciting topic. I love your term, finding the common ground, because we're literally talking about the ground. And in some cases, we're talking about relatively small plots of ground. And I know you and Ted has mentioned also this issue, that one of the issues of combining interesting data is the issue of potential mismatch. And mismatch may be one of scale, of granularity. So you have the types of data that you want for weather, soil, blah, 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 whatever it is that you're collecting. But some of those data sets are collected. Ted, you've talked about this some the scale doesn't match the scale of the individual farm, yet the issues are very micro issues for each different place, right?
Yeah, so you see this over and over again. Census data in the US is gathered on one geographical unit basis, and farms are denominated in township and range, and weather data is on some sort of strange equal spaced grid of latitude and longitude. And trying to decide what's going on there can be really hard. And GPS, for instance, doesn't even necessarily solve the problem when you don't know what the boundaries of a field are. And so it's hard to tell if a sensor is in a particular field. And so trying to coordinate these things, trying to resolve to a common frame of reference, I mean, it's simplest to understand the problems in a geographical sense. But other kinds of data have the same problem. Who is who? What does identity mean? What does geography mean? What does even time mean?
Okay, so those are some of the challenges. So let's go back to Suparna and give us some hope here. So you've mentioned
She's obviously the hopeful one. I've torn all my hair out trying to work on this.
But you've mentioned that there are many different issues that have to be solved, and communication is a tremendous one. But the use of metadata at each of these different places can help with some of the issues that you've mentioned, that Joanna's mentioned, that Ted has mentioned. And I'm curious, I think you've told me this, but I want to verify it, that so if metadata can help, we know more about the data, we know what's in the data, how it was collected, when it was collected, who collected it. Also, hopefully some kind of history of the data of who's using it, because somebody later can learn from it's already been used for the source that builds common experience. You don't have to do everything yourself. But let's say if it's the data producer, the data curator who's inserting the metadata, then you have the challenge that they don't know yet who's going to use it. Back to this idea of context. So, what does the metadata, do you have to know how the data is going to be used before the metadata is inserted?
So, I mean, this example that Ted just talked about, just the geographical metadata. So you don't really need to know what it is going to be used for. It's really just how it's going to relate to other data. So it's giving you, some dimension on which you can relate to other data. So it's both ways. I think there's some metadata that it's good when you know the context in which it's going to be used, but there's quite a bit of metadata that just allows you to match things together. And I think the problem with this, with metadata in general, is that it is hard work to add metadata. So we would all love to have more metadata, and then you want to have metadata, metadata about the metadata to understand it. But it's hard work and it takes effort to do that, as you're saying, right? The producers have to put in a lot of hard work. So what we've been trying to look at is how can you inject metadata automatically? Can you, with advances in AI techniques, for example, if you want to say field boundaries, you could probably have AI techniques that could actually look at the fields and be able to detect those boundaries and automatically inject this metadata about where that the data, that field information is actually coming from, and that allows you to connect additional data. You can, as you're saying, as the data is getting used by people and it's being used automatically by in models. So if you see that two pieces of data were used together, then that's giving you context about the relationship between the data. And maybe that can be added back as metadata. You get to see the behavior, as I'm saying, that maybe you've trained an AI model on some kind of data, and then you are using it in the, say, this agriculture example in the field, or maybe you're using it in a factory production. So you want feedback about how that model is behaving in the real world and whether there's a drift from that or not. And that measures are also metrics that are getting collected automatically that can be fed back as metadata. So there's a lot of things that are automatically generated as people are working with data. And if we can somehow capture that information, then that makes it much more easily usable as metadata. And then that, it's not enough because you still want the human input, you want the domain knowledge, but it reduces the load so much that the humans can intervene in places where it's really necessary.
So and doing it automatically makes us practical when we're talking about working with data on a huge scale. But then the human decisions about which parts do you actually capture, which ones do you inject, again, that goes back to context. And I love this example that you're giving, because that kind of solution, as I understand it, affects the value of data, the flow both ways. The producer, here's the data scientist using the data, delivering the insights, but you're collecting that new data from the context of the end user, but also how that particular data was used, which is something I think that of all of it, that's the thing that people maybe are least likely to say. There's value in knowing who else used this for what purposes. Did they combine it with other data? Did that fall on its head, or it was actually interesting? Insights.
And that helps with this whole factor of trust, right? I just had to bring it up because I work in trustworthy AI. And so the question is, how do I trust the data that I'm getting? So it's easier when you know the source of the data. But then as people are using it, you can maybe have do some quality tests on the data. You figured out that as you use this data in this condition, it worked well, and here it gave you biased results. So that's you can actually run tests. People could potentially run tests on the data and feed that information also back as metadata.
And practical experience is, in some sense, a test of the hardest kind, and so feeding that back so that there can be a wisdom of crowds there. There can also be a delusion of the crowds, and that can be difficult to distinguish. But that, this field is called this, which who knows what that name means, and it's measured in dollars. Well, thank you. I mean, that's nice, but what does it really mean is a much deeper question. What is authoritative? What has been in the past useful, and for which purposes, is a kind of metadata that I think Suparna is alluding to, that is very, very deep and can be difficult or impossible to apply intentionally by some godlike expert, because those godlike experts don't exist.
And, it's so important, this mention of trust. I just want to inject this idea. Building trust with data isn't just a matter of saying, do I trust the organization, the people using it, that they haven't injected intentionally evil things, though that matters, absolutely. But let's assume all the players are players with good intention. There's this issue of trust with unintentional bias and drift in data. There's trust in terms of what people think they were collecting. is it really what they thought they were collecting? I mean, there can be mistakes. The data set, has it been labeled properly? I mean, it really comes into it at all levels of to what extent can you trust that data, and is it technically correct? And Joanna, you deal with this, I would think, across all the different organizations because you work with many.
It comes back down to trust. It's a multidimensional thing. It's not just a single player. So it's wonderful to get a data set where I can trust that the data is what it says it is for various reasons. But I also, if I'm building, for instance, a predictive model for a client in the retail space, and I go to an external source for weather data to find out whether it was raining on that day and see if that makes the sales predictions any better, I don't just need to trust that that is accurate weather data. I need to trust that my client can continue to run data on that into the future, and that if any changes are made to that data, they will be constructive and they will still work to the purpose that I'm giving to them. So there's a level of trust which is about the information itself that I'm looking at as the data scientist that I can then assess using my technical knowledge. But there's a level of sort of organizational trust almost, where it's not just about what I'm seeing, it's what I expect to still be there, and what I can say to my client that yes, you can on an ongoing basis continue to make your sales predictions based on this information, because this organization is trustworthy, because this organization has somehow certified that it will be maintained into the future. All of these different aspects of things that change whether or not I can say to a client that I'm working with, yes, this is going to keep working for the next 2 years or 3 years or 4 years, and you can trust it.
Yeah. And
I've actually seen quite a few cases where somebody fixes data, makes it more correct, and breaks systems downline because they had paradoxically depended on the incorrect function in ways that nobody understood. The system was valuable, it produced good results until it was corrected, which is a nightmare scenario.
So again, better information about data, better metadata, and how you can track governance, how you can track usage, would at least help when problems like that arise, right? That at least you can figure out more what quickly what happened, what broke, what changed. And by the way, we've talked a lot about weather data and agricultural data. I find these really interesting, but these issues apply whether we're talking about financial data, manufacturing data, customer transactional data, it's web interaction data. It's all of these issues still apply. It's not specific to the type of data. Ted, you've mentioned some work that you're doing with HPE. You said you have different hats, although I noticed today you don't have any hat. There's no hat.
Lost
there
my
should
hat.
Be the lossless hat. But in addition to working with the HPE Emerald Data Fabric, you're doing some work to help with these large data initiatives. We've mentioned Agstack. I think HP is a partner with Gaia-X, which is a European-based one. Suparna is working with some of the partners. But HPE also has a new initiative or a new project called Data Spaces. And tell us a little bit about what's being done to help make these new data initiatives known and available, and basically the plumbing so that data access isn't so difficult.
Yeah, and plumbing is often the most difficult part of any of these things because it involves all of the issues about metadata and provenance and change control that we've talked about. And you can't just control these things. You must improve them, but then you must not. And it's that dilemma that leads to the real problems. And so Data Spaces is taking a view across multiple industries, from medical and healthcare, agricultural, manufacturing, one that I just, financial, of course, others that I'm not thinking of right in the moment here, but trying to build systems that enable this sharing as appropriate, where appropriate, and as easily as possible, both in the discovery phase, so you can discover that this kind of information may well be useful in your application, even though you had no idea that can be a collective fact that you can derive. And then to help you understand how that data can be used and what it really means at this high sort of level. So data spaces is essentially trying to help with that plumbing problem, both philosophical plumbing and very, very pragmatic plumbing.
Well, we're soon going to go to the question and answer, but I have one short question left for our other two panelists, and that is, with the organizations that you're working with, the type of work that you're doing, particularly Suparna working with metadata, what are the data needs that you see people looking for? What are the data sets or the data initiatives? Where are their interests? So what are some of the large data sources that you see people interested in? Let's start with Suparna.
So I think I see a lot of different variety of it, because depends on every partner that we're trying to work with. It's very different. So yes, there are some common open data sets that we keep talking about, which is weather and those conditions, demographics. But I think some organizations, for example, they can't even leverage the data that they have within their company. So that's one of their big challenges. They're having tons of streaming data. They have tons of data in their company, but they don't know how to utilize it because they don't understand and interpret it. While there are other organizations who are trying to really use external data in combination with the data that they have, and then and be able to connect those two kinds of people.
So these same principles that we've been talking about of how do you find data, do you trust what's in it, what's the history, the story of the data, how does metadata help, what about trust, do you have the good data infrastructure, actual physical platform to deliver and give access, but access that is very, very flexible across a number of different users, a number of different types of tools. And we're talking about that where you're going between these big different external data sets, but all of that would apply for an organization if they don't even look outside their own doors, within their own organization. How do they use their own data? I think all of those same issues and fortunately all the same solutions apply. I mean, everything that you've talked about would help if you're just using your own data, right?
And oh, go ahead, Suparna.
So I was just saying that sometimes in order to know if the data is useful, you have to go through a lot of this effort of bringing that huge amounts of data over and then doing a lot of this plumbing and doing everything and then figuring out it's not really suited for my purpose, and then going back to the drawing board. So that's why it helps to have a solution where you have both the infrastructure components plumbed in together very easily, as well as having this kind of easy discovery and metadata on the top.
And I think that the only measure of is data valuable is to try to prove the pudding. Does it actually demonstrate value in a pragmatic sense? And therefore, since you are trying to find things that you didn't expect, which means you didn't expect them, you have to try them. The empirical approach, ultimately informed by experience, informed by expertise, informed by philosophical thoughts, all good, but you have to do it. And it's very, very hard to predict.
And let's close.
Sorry, Ellen, just a moment. I occasionally think about the phrase data is the new oil.
Oh, yeah.
And then the phrase the data is the new oil, the idea is that it's a lot of value there. But if you think back, there must have been a time when people struck oil and it was a pain in the neck. So like, what is it? I'm covered in black sticky stuff. What is this? And it was only when we started to build the infrastructure to develop it, to make it into the pharmaceuticals, the plastics, the petroleum, all of the different uses that we now have for oil. Once they became available, then yes, it became highly valuable. And I suspect that we're maybe in the early stages of that with data as well. I love that. I love that as an analogy that maybe goes a little deeper than you originally think. Data is the new oil because it's only of value if you know how to work with it.
Yeah.
I think that's important, but I think we also need to go behind that analogy a little bit. because information can be used twice and oil can't. And oil can be used in very fungible, commoditized ways, and data can't. And so it's cranky and valuable and wonderful, but it's also cranky and hard to use in very, very odd ways. We can't be captive of that metaphor. We have to see it as it is as well.
Absolutely.
Looking at the questions that have come up here, I'm going to go, one of our first questions, and these were already answered in the chat, but I want to bring it into a discussion for the whole panel. This first question, thank you, Michael, was talking about the tools that facilitate data sharing and data science workflow. And he mentioned Apache Arrow. Ted's talked a little bit in the chat in the answer about Arrow. But let's talk about that for a minute. Whether we're talking about internal access to data, being able to tap in and actually use the data that you have, or getting access to somebody else's data set, which again may have a geographical distribution issue. Besides the individual tools, and let's talk about a few, but what are the actual issues that the tools need to solve? So I see Joanna nod. I'm going to jump on you.
I was actually thinking that there's problems that the tools can solve, but there are also problems that the tools can't solve, and that we as people and organizations need to get together and solve. A really interesting one is commercial sensitivity, because I've seen a very conservative, in small c conservative, attitude in some organizations where they know their data is valuable, they don't really know how to get the value from it, so they're going to lock it down, keep it really secret, make sure nobody knows it's there, and just hope their competitors never know about it. And that is obviously very limiting for getting any value from it. It doesn't facilitate data sharing, and there's no amount of tools that can surmount that problem. So there's a big organizational effort and attitude change almost in understanding, when is data commercially sensitive? When does it matter that it should be kept private? But when is it much more valuable to this organization as well as all the competitors for it to be shared? And we saw that with mobile phone masts, cell phone masts. When originally they came up, they were specific to the organization that put them up. And if you had your phone tied to that network, then you could have signal. But if you were in an area that had a different mobile phone mast, you might never have signal. And it took time and it took effort for us to get to that point where we could share access to that terminology. And we are all better off because we can, except perhaps the people who are running the mobile phone networks. And I don't think they're in any danger anytime soon.
And that sharing is another property of information that is very, very bizarre. With oil, 2 barrels are worth twice what 1 barrel is. But with data, 2 barrels of data can be worth 10 times what 1 barrel is, because that synthesis can very often increase the value of each side. Very, very hard to predict again, but extraordinarily powerful. I got to see this firsthand many years ago in a financial startup I was involved in, where they were able to find fraud better because they had data from a number of banks. And that then helped them sell to new banks and get more data. And competitors were unable to really compete with them because they would go to banks and they would say, let's do a head-to-head evaluation. Their models weren't as good, so they couldn't get data, so their models weren't as good. Whereas H&C's models were better because they did have the data, they moved first, and therefore they could get more data and they could build better models. It was a very, very powerful effect that had profound implications for finding bad actors who couldn't just go from bank to bank and play the same tricks again.
Yeah. So maybe one of the things that the tools need to enable, back to the question you asked, Ellen, was that if the tools can enable this, make people feel safe about sharing the data, because why is it that they don't share? If you see, for example, if you look at medical data, right, there is a sensitivity to it being tracked down to the individual. So there is a privacy issue. There are some of these reasons why people aren't sharing, but they are in the process, you're locking out too much, which could have been shared. So we need the right tools that will let people share, without revealing exactly the sensitive part of that information, but have everything else be combined in this kind of a manner, and to enable that kind of exchange.
So it should become easy to manage those different options, and then it's the human choice as to which option.
And maybe if you have a confidence of what the data is used for, that it's not used for a malicious purpose. I mean, it's, so that's really what they want to guard against. So that's one of the things that we're seeing with many of the groups that we are working with, many of the partners, they have the same kind of concern.
We have another question here, and I'm going to throw this one to Ted because it asks a question about data in the US, and it's not a question I know how to answer. So Ted Shakuntala, thank you for asking this question. Ask, where can I get data on social determinants of health in US besides credit bureaus?
And there's a key thing there. Social determinants of health is a term of art with the credit bureaus for data that they synthesize from a large number of inputs. And most of the inputs that they use are, in fact, I was just typing this, that's why I looked distracted there for a moment, are actually public data sets. The credit bureaus have brought together that data, and their data scientists have synthesized then a broadly useful indicator, which are these social determinants. And they now sell that as a product, which is a synthesis of this. So you can actually go back and get almost all of the data that they have, the public health data, the census data, some of the economic data, and other aspects in order to drive out those same value points. But it's a lot of work. And so essentially that's what these credit bureaus are charging for, is the history, the expertise, and the experience that they've used in encoding those indicators.
And elaborating a little bit, one of the other questions, Ted, that you answered in the chat was asked by Asit about what architecture is the future of data sharing, centralized or decentralized way. And of course, we both work with a technology and architecture that is intended for this type of thing with the HP Ezmeral data fabric. But Ted, what are the fundamental capabilities, regardless of which tool somebody takes? What are the fundamental characteristics that an architecture that supports this type of data sharing needs to have?
Yeah, and you may notice in the Q&A panel, the answer I gave was a complete non-answer in some respects. I basically said both, and it depends. Which are all of the computer science traditional answers. Decentralization is absolutely required in many cases because the volume of data is just too large to move. So it physically can't be centralized. Centralization in some form, even indirect federated centralization, is required for other problems. Like, what is the total number of people that do X? You can't get a total without bringing all the pieces to one place and adding them up. Most machine learning models are very, very fancy forms of totals or aggregates. And so centralization is required to learn across broad sort of experience. And there are different techniques required at different levels. So there is no single answer there. Both, I think, are absolutely required across many, many sorts of situations.
And so if you have the assumptions on the human side, the stakeholder side, the metadata in place, the tracking of data, the data trust, if you then have technologies, infrastructures that support this movement or not, access of data locally or not, then you can work with basically a single infrastructure, which would be nice, but the choices of centralized or decentralized become driven by the individual project and the individual need. Does that make sense?
Yeah. And
Okay.
need and constraints. Sorry.
No, it's okay. And Joanna, just a little, because I'm less informed about what's happening within Europe. I know a little bit about Gaia-X, partly because HPE is a partner, but I don't know really what's changing in terms of the open data initiatives that people are using.
I think open data is a massive thing in Europe as much as in the US. Obviously, the internet makes this a very global effort. So progress that is happening in one part of the world is very much seen in other parts of the world, and sometimes when it's useful, duplicated. And we're seeing a lot of different institutes that are specialising in bringing particular types of data together, becoming a single source almost, if you know that you need to work with a particular type of data. So in Scotland, for instance, we have the Urban Big Data Centre, which is talking about city data about information about cities and what's happening in cities. And they have they're a massive data catalogue, lots of information that you can use, sometimes for sale, which is an interesting development as well. Lots of different maps are being more centralised, local government efforts, as well as certainly in Scotland, it's Scottish government level and the UK government level. We've got lots of different government levels in this place, and they're all moving towards more open data. And I think we're starting to see from public officials, that transparency is something that the electorate values, that we want to see how they come to their conclusions, and we want to understand, and we want to use the expertise that our population has and allow us to, instead of having single experts in a single team, it's much better to use that information across the electorate to verify what's going on and make sure everything's above board. So I think there's a lot of movement in that sense to be more open, to be more transparent, and to build trust in these ways.
Yeah. So panel, I think we're at the top of the hour. I thank you all very much. And we're back to Maddie. Thank you for having us. And I think you have some closing words for us.
Yes, thank you all so much. I had such an amazing time learning all about data sharing and the different challenges and initiatives and different available data sets. We had so many wonderful links that were provided by our panelists, and I did drop them in the chat. I'll go ahead and also post those on the Meetup page, so you guys can always find those later on. This session will be sent out to everyone automatically tomorrow at the same time. So check your email for the recording. And thank you all for joining from around the world. And thank you to our amazing panelists and speakers. This was such an incredible conversation. I hope everyone enjoyed, and have a great rest of your day or evening or sleep. Take care, everyone. Thank you so much. Thank you, guys.
Thank you.